Am I even? Where is my screen? What happened to this? Is it working? Not very sure. Yes. This is gone. Can't see this. Okay, it is working.
What happened to this?
So we are watching Codeforces yesterday's contest. I uh I was able to do two questions, though I think I could have done B and I could have also done D, but I did not understand B. And D, I had a small issue at the end which did not I did not understand how I would solve that issue, but so that's why I missed that. But I was able to do two. Yeah, it's my second code forces contest ever, so I'm happy about that. But let's see the answers.
This is TLE Eliminators, and I am Shomoji Chatterjee. Welcome to the post contest discussion of today's Code Forces contest. Uh, I sorry for the delay. Actually, there was some problem with the Meet link. Some people were not able to join, and I was also facing issues with the chat. So let's start without. Okay, so this was the problem A of the contest. It says shape perimeter. So it asks that there is an m by m square stamp in left corner of the paper. You are given two integers. Move the stamp xi units to the right and yi units upwards. Press the stamp onto the paper, leaving an m by m colored square at its current scale. Then it says that the colored shape on this. Okay. So here it is. The problem gives us as input in pairs of values, and it also gives us an where this length is m at a direction. You keep on shifting, and you need to find the perimeter of the shape. Let me explain this. So basically something like this. So suppose this initial value is x1, x1. This is y1. Initially the stamp was at origin. It has been said the bottom left corner of the stamp was at origin across m shape here, right? So this is m and this is m. So how does it look like? You basically shift this, and the next is a new bottom left stamp. Even this values area, it starts from here, it goes here, it starts from here, it goes here, and then it comes back like this. So basically this is the perimeter of the region, right? The boundary, and this is what you need to find. Even if you can look an example, they had given a diagram here. So these are region. Okay. So is the problem statement clear? Understand how can we solve this? Okay. So first of all, try with smaller test cases, and then we will try to extend the logic. So initially, suppose this was 0, 0, and I shifted it to somewhere at x1, y1, right? So this distance is x1, so this distance is x1, and this distance is y1, and it shifted it, we do not shift it further. Then what should the answer be? Anyone?
OM.
Great, great. So if the value of n is 1, then the perimeter is simply the perimeter of the square. Now, so it is simply the perimeter of the square. This is an m by a shifted by a distance x2. So this is x2, so I keep it somewhere like this at this position, and I also shift y2 here. So this value is y2, and this is my new coordinate. So here is my new coordinate basically. So now my stamp paper looks something like this. This is again an m by m square. Okay. First of all, I would like all of you to observe that this constraint, it has been given that xi and yi lies from two squares. Then this shift is actually lesser than this entire length of the square. So that is, suppose, let me call this square S1 and let me call this square S2. Center of S2 minus some duplicate region, right? Minus that, suppose I have two squares. So I have this square 1 remaining part, isn't it? So this entire length needs to be counted. So what I'm saying is, what I'm suggesting is that why don't you add up both the perimeters? Like if you add up both the perimeters, you count basically this entire thing, you count this entire length, boundary length once, and then you count this entire boundary length again once. So what is the sum of the perimeters? The sum of the perimeter of S1 is 4m. The sum of the perimeter of S2 is 4m. But then look at this. When you calculated 4m for S1, you took this extra part. So you look at this part. So this part was something which is not a part of the perimeter. It comes inside the region, but still you have counted it in this 4m. Similarly, look at this part. Fine, call this. Any guesses? Similar logic. If you look at this, the perimeter of the square is. Okay, thanks. Great. So is it clear how does the idea extends when you have a large number of problems? Okay, so let me read this problem. Size n. The graph is constant
Yeah, so I did it very similarly,
4m. That basically adds the perimeter of that square plus 4m.
but I did it like this would be x2 and this also would be x2. This is y2 and this also is y2. So I did not do, I made the answer 4 into m. And at the starting, I took answer as 4 into m, which counts this, 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 and this. And then for every extra position, let's say it was at 1, 1. Now the shift is 2, 2. Let's say the shift is 2, 2. The initial position does not matter. So the x2 is 2 and xy2 is 2. So I did add up x2 plus y2 and I multiplied it by 2. So because this will also be y2 and this also will be x2. So that's how I solved this. And it is very similar, but a little bit more easier and optimized.
problem. Okay, so let me read this problem. It says that you are given an undirected
I did not understand this question. I did not understand this permutation part.
graph with n vertices labeled from 1 to n, and this graph encodes a hidden permutation p of size n. The graph is constructed as follows. For every pair of integers I less than j, an undirected edge is added between vertex pi and pj if and only if pi less than pj. Okay, note that the edge is not added between vertices I and j, but between the vertices of the respective elements. Refer to the note section for better understanding. Your task is to reconstruct and output the permutation p. It can be proven that the permutation p can be uniquely determined. Okay, great. The value of n is given till 1000. That gives you a hint that an order n square code or a quadratic code would also work. So the constraints which are given usually give a hint on what approach can be found out. Okay, so let me first explain the problem statement. What does the problem statement say? The problem statement says that we will be given a graph. So I think it's usually not that common to see graphs as problem B of a div 2 contest, but it's okay. Not any graph algorithm was required to actually solve the problem, so it's fine. So what is input? The input is given as a graph. So what is a graph? Graph is a set of vertices and edges. So it is said that you are given a graph with n vertices. It can be anything. And basically, you need to output a permutation. You need to output a permutation. Okay, first of all, for if someone does not know, though it is a very valid and standard concept, a permutation of say some size n, a permutation of size n is simply some reordering of the array 1, 2, 3, dot n. So if you can reorder 1 till n and get something, then we call it a permutation. For example, let me ask you a few questions. So is 1, 2, 4, 3 and 1, 3, 5, 2, are these valid permutations? So this is the first one, this is the second one. Anyone? Are these valid permutations? Uh, okay, great. The first one is a valid permutation, the second one is not. All of you are fine. Sriram, 2. Are these valid q dot n of size n is simply some reordering of the array 1, 2, 3, dot n. So if you can reorder 1 till n and get something, then we call it a permutation. For example, let me ask you a few questions. So is 1, 2, 4, 3 and 1, 3, 5, 2, are these valid permutations? So this is the first one, this is the second one. Anyone? Are these valid permutations? Uh, okay, great. The first one is a valid permutation, the second one is not. All of you are fine. Sriram? No, it is not a pure graph problem. Only the input is given as a graph. And even if you have not done graphs earlier, I would try to make you explain the solution. That's fine, right? Okay. Okay, so you're right. The first one is a permutation. This is a permutation of length 4. The second one is not a permutation because if it is length 4, this is not a valid rearrangement of 1, 2, 3, 4. You can't rearrange 1, 2, 3, 4 to get the array 1, 3, 5, 2. First of all, because how does this 5 appear? Second, you can't have repetitive elements in a permutation. So like 1, 1, and 3. Now, this is what the question says. So let me explain the question. The question says that they follow some procedure or some policy to take a permutation and then construct a graph. So suppose they take some permutation. Let me explain this using an example for concreteness. Let us take an example which they have given in the test case that may help. Okay, so let me take. So first of all, let me tell you the procedure. So they say that given some permutation. So suppose they have given some permutation 4, 4, 2, 1, 3, 5. Okay, just a second. Yes, okay. So suppose they have given you this permutation 4, 2, 1, 3, 5. They said that they will follow some procedure to construct a graph from this permutation. What procedure? So they say they will do something like this. They will take a vertex. So they will make a graph with 5 nodes. So this is the graph they are trying to make. So you have 5 nodes in this graph. 1, 2, 3, 4, and 5. How will they build the graph? First of all, the graph is undirected. That means the graph has edges have no directions. So they say you take the permutation 4. You look at all the right side elements and add an edge whenever you find a greater element. So look at 4. Look at all these right side elements. Do you find a larger element than 4? Yeah, you get 5, right? So add an edge between 4 and 5. So let me add an edge between 4 and 5. Fine. Now come here. Look at 2. How many elements you see larger than 2 here? You see 2 elements, 3 and 5, right? So add edge from 2 to 3 and 2 to 5. So add an edge from 2 to 3 and 2 to 5. Now come at 1 here. Come at 1 here. From 1, how many elements do you see larger than it? You see 3 and 5, right? So that means add an edge from 1 to 3 and 1 to 5. So let me do it. So take 1, add an edge from 1 till 1 to 3 and 1 to 5. Now come here. Come at 3. How many elements do you see on the right side which are greater than 3? There's only one element, right? 5. So add an edge between 3 and 5. Now come here at 5. How many elements do you see at the right of 5? There are no elements, right? So you do not need to add an edge. So this is the graph which you build. So it says that given a permutation, there is some process to build this edge, to build a graph. Now what does the question says? The question says that they will not give you this permutation. They will not give you this permutation. They will give you this graph. So they will provide you with this graph and you need to output the permutation. So they will not give you this permutation 4 to 1, 3, 5. What they will give you? They will give you this graph. I will explain how this.
Okay. I was thinking there is something that I have. Okay. Now I understand the question. Now let's see how will I solve this. So 2 is connected to 3, 2 is connected to 5. So 2 comes before 3 and 5, and 1 comes before. So instead of having this, I would just have a directed edge from 2 to 3, 2 to 5, 3 to 5, and I'll do a topological sort. 2 to 3, 2 to 5, topos 3 to 5, 1 to 3, 1 to 5, and 4 to 5. And I'll do a topological
this graph
sort.
is given. But suppose they give you this graph as input, and then they ask you, okay, tell me what is the permutation from which this graph will be constructed. If you look at the second test case, this is what has happened. They have given this graph as input. If you look a bit carefully, you will realize if I've drawn right and have not made any mistakes, that these two graphs are same. Okay, let's check once. Yeah, so you can see that these two graphs are same. There is an edge between 4 and 5.
Upper portion of the graph. Topological sort on the upper portion of the graph, I think. Let's go into this. I was able to get into this 4 questions. Oh, mm. I was thinking like we'll have to do toposort somewhere, but I'm not very sure. So 1, 2, 3, 1 to 5. So upper portion, I count the upper portion of the graph and I'll do a topological sort on that. Yeah, that makes sense. Let's see. 1, 2, 4 to 4, 4 to 5 there is. So 4 will be the there's an inbound so 4 does not have any edge, no? That comes into it. Yeah. 4 does not have, so 4 will be in the queue. Now let's just mark down all the edges. Galley draw. Uh 1, 3. There's an edge between 1, 3, 1, 5. There's an edge between 1, 5. 2, 3, 2, 5. 2, 3, 2, 5. 2, 3, 2, 5. Okay, next. 3, 5, 4, 5. 3, 5, 4, 5. Good. Now 1 does not come at the end. 4 does not come at the end. So Q will have 1, 4, 2, 3, and 5 do come. So yeah. So I'll add 1 to the answer remove 1, 3, 1, 5. I'll add 4 to the answer. 1, 4, remove 4, 5. I'll add 2 to the answer. Remove 2, 3, 2, 5. And 3 will come here. And okay, 1, 4, 2, 3, 5 would be my answer, but that's also a correct answer. 1, 4, 2, 3, 5. Okay. I now understand this question.
5. So here it goes. There is an edge between 4 and 5, and then there are edges between 2 and 3, 2 and 5, 3 and 5. When I understood the question properly, understanding the question was important here. Okay, Advait. So I just great. So since the question is clear, let us try to understand the solution. Okay. So first of all, what did I say? I said that they will give me a graph as input. Great. So how can a graph be given as input? Any idea? And this how is graph given as input? So here we were given an adjacency matrix. Okay. So what we were given an adjacency matrix. So what is an adjacency matrix? So let us take this graph for example. Let me draw this graph again here for simplicity, so that we do not need to look. So here we had 5 nodes. So we had 1, 2, 3. We had a 4, and then we had a 5 here, and the edges look something like this. So there is a 2. There is an edge between 2, 3, 2, 5, 3, 5, 4, and from 1 there were 2 edges, a 1 to 5 and 1 to 3. Okay. If I'm mistaken, let me check once. Okay, looks correct. So suppose if the question setter wants to give this graph as input, let me show you how will he give us. He will give us in the form of an n cross n matrix. So he will try to give us this as the form of an n cross n matrix. How will he give us? In the first row of the matrix, he will look at 1. So let me draw the matrix. So basically this matrix has 5 rows, 1, 2, 3, 4, 5. Okay, and it has also 5 columns. So here comes, just a second. Just a second. 1, 3, and 5. Okay. So at 3 and 3 and so 2 is a neighbor, 3 and matrix. The best part about an adjacency matrix is that if you want to check, okay, do I have an edge between 2 and 5? Then you just go to the second row, look at the fifth entry, and see if it is 0. Look at the fourth column, and as input, then we will be given this adjacency matrix as input. Even if you look at the CF problem, okay, so is the input format clear? I think most of you were accustomed with adjacency matrix. Okay, great. So now let's discuss the problem. So first of all, forget about code and everything. So let us just look at this graph. So let us just look at this graph. Let me draw this graph somewhere here. So we had 5 nodes, 1, 2, edge between 4 and 5, 2 and 5, 2 and 3, 3 and 5, 1 and 5. We need to output 5 integers, which must be some. Most interesting position is 1, right? Why is 1 the most interesting? Because remember our algorithm to convert from a permutation to a graph. If I had 1 somewhere here, then all positions which are to the right of 1, they has to be greater than 1 because 1 is the minimum element. So all positions which are righter to 1 must have an edge between 1 and itself. So that means you can simply look at 1 and look at what all neighbors 1 had, and you can simply understand that okay, which part should lie to the right of 1 and which part should lie to the left of 1. For example, just looking at this graph, I can understand that okay, 1 should be somewhere midway there. Not have 1 as right side, which I have in the array is interesting because it helps us to bifurcate the array into 2 positions. So since I get the position of 1, I know that okay, 2 and 4 has to lie somewhere here, and 3 and 5 has to lie somewhere here. Great. Now look at this left portion. So let me do this. So basically we had 5, we had 1 here, and then we know that 2 and 4 must come at this part, 3 and 5 must come at this part. Great. Now look at this part. I'm interested about this part of the problem now. I know that there are 2 possible elements, 2 and 4. Always look at the minimum element. The minimum element is interesting. So look at 2. So when you look at 2, is 2 a neighbor of 4? No, na? So 2 is not a neighbor of 4. That means here 2 must have come to the right side of 4, right? So here 2 must have came here. Why so? Because if 2 would have come here and then 4 would have come, then there would have been. Similarly, by the exact same logic, if you look at 3 and 5, take the minimum element, 3 and 5, 3 must have came to the left side of 5, right? If 5 would have come before, just a second. Yeah, if 5 would have come before 3, then at the right of 3, that 3 must have came. What you can do is that you can continuously try finding the minimum element of this range, or you can just iterate over 1 to n. So let me explain. So there are multiple ways to solve this. Like one way is that you take this portion, and in this portion you find the minimum element 2, and then you try to find the position of 2. Now you come to this portion, then you find the minimum element 3, and then try to find the position of 3. This is one thing you can do, or you can just make, or what you can do is, or what I have done is simply run a loop. Simply run a loop for I equal to 0 to n minus 1, and or we can say for I equal to, just a second. Yeah, simply run a loop for I equal to 1 to n, and then
Oh, my solution was not a correct solution.
try to find where I can be placed in the array. I will try to explain it using a larger example, so to understand what has actually happened. So suppose you have been given a large graph. Suppose n is quite large, so there are a lot of positions. So suppose there are a lot of positions. So what will you do? You first look at 1. So what is the value of n I have taken here? I've taken n as 4, 8, 12, and 13. So I've taken n as 13 and can be anything. So suppose n is 13. I initially look at the graph. Okay, instead of using such a weird test case, okay, we do not have some good test case here also. That's fine. Yeah, so the idea is that suppose the value of n is 13. What do? I basically I take the graph and try to find the position of 1. So what will I do? So I will try to find the position of 1 first. So suppose 1 comes here. What do I mean by 1 comes here? That means I know all the neighbors of 1. All the nodes which have edge with 1, they must come to the right side of 1. And all the nodes which do not have edge with 1, they must come to the left side of 1. Right? So that means you always get, when you start with 1, you get the position of 1, and then you also bifurcate or break down the problem into two different subproblems, which are one to the left side of 1 and one to the right side of 1. Isn't it? So suppose you break this, and suppose you break this into a bunch of values. So suppose you get 3, 5, 8, 10, and 12 here. And all the remaining values, that is 2, 4, 6, 7, 9, 11, and 13 here. Okay, so what does that mean?
Chalo, 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 shallow, shallow. Let's do this.
That means that all these nodes, 3, 5, 8, 10, and 12, were actually neighbors of 1 in the input graph, and all these nodes were not neighbors of 1 in the input graph. Great. Now, try to find out where can I place 2. So I placed 1. Where can I place 2? So if you want to place 2, what do you basically do? You basically look at this part of the array. So you just look at this bunch of elements and try to find out how many nodes have edges with 2 in this bunch of elements. So suppose 2 has edges with 6, 7, and 9. So suppose 2 has edges with 6, 7, and 9. What does that mean? That means that 6, 7, and 9 would have come to the right side of 2, and 4, 11, 13 would have came to the left side of 2. So where should 2 be placed? 2 should be placed in such a position so such that you get 3 places to fill 6, 7, and 9, 9 to the right side. So that means 2 must be placed here. So now look at how the problem has changed. So initially we had this bunch of elements. Now we've got 2, right? So if you have got 2, so basically this is where 2 is. Now the problem is broken down to a bunch of numbers. You have 6, 7, 9 here. So you have 6, 7, 9 here in this part. And in this part, what are the values which are possible? You can put a 4 or a 11 or a 13. So that means that every part, at every time, you're basically finding the position and then you're breaking this stuff into smaller portions of the problem. Look at this part. Suppose you are now analyzing 3 and you saw that, okay, 3 has an edge with 5 and no others. That means you know that 3 has to be placed. Where does 3 need to be placed? 3 needs to be placed here, right? So that there is only one position remaining where 5 can be. So 3 needs to be placed here. So that again breaks down the problem into two subparts. So since 3 is placed there, you know that, okay, there is this region where 5 can be placed. And then there is this region where 8, 10, and 12 can be placed. Okay, so I'm trying to explain you how the problem is getting divided and broken into smaller and smaller parts. Basically, what you're doing is you're iterating over 1 to n, and you're trying to find the position of every element by looking at the graph, which one are neighbors and which one are not. So now let me show one more example. Suppose you are here at 4, and now you analyze the graph. How many edges are there between? Let me ask this one. Anyone in the chat, where should 4 be placed?
Adjacent of 2.
Correct. 4 has to be placed at adjacent of 2. Why? Because there are no neighbors. 11 and 13 both are not neighbors of 4. That means 11 and 13 both has to be the left side of 4. That means 4 needs to be placed here. So again, the problem breaks down into a smaller subproblem. So now you don't have this entire region. You have this region, 11 and where 11 and 13 is there. So if you can compute or you can try run this algorithm every time, so finally we'll get the position of all elements. What remains as a challenge to us is analyzing or understanding how in our code we can try or keep track which element comes in which range. Like 6 can lie only in this range. So basically, like look at how the algorithm started. You put one in some part of the array, and then you broke the array into multiple parts, right? But then you broke the array into multiple parts, so that is something which looks good when you say it on paper. But how can you implement it in your code? Okay, so this is an idea which will come handy or which will come useful to you in many problems. Like in many problems where you see a pattern that, okay, the problem is breaking down into smaller subproblems, and every element 6 can actually be in some range of the array. So it can be from some range L. Let me try to maintain two arrays L and R. So Li means what is the leftmost position where I can be at? What is the leftmost position? What is the leftmost position I is allowed to be at?
0.
Excuse me, anything allowed to be at? So yeah, as some of you were saying, we initialize L of I as 0 and R of I as n minus 1 for all the elements. Is that clear? Why do we do so? 1 they can, or 1 to n, they can be anywhere in there from index 0 to n minus 1. That is clear. Now what do? Now here is where things become interesting. So suppose you now analyze 1. When you analyze 1, you broke down the problem into two arrays, right? So when you broke down the problem into two arrays, you get a bunch of numbers which can be at left, you get a bunch of numbers which can be at right. So let me call this index. So let me call this index. Suppose there were some left bunch of elements which I initially wrote here, right? So there were some 11, 13, 4, 2, 6, 7, 9, right? So what changes you should make in your L and R values of them, and R becomes cos minus 1. Okay, L is same and R becomes cos minus 1. So L remains same, R becomes cos minus 1. Great enough. Okay, and what changes to the right part of the array? So at the right part for this bunch of elements, what changes we need to make at L and R? We simply keep L as cos plus 1 and we keep R as same. That's fine. So this is actually an idea or something which will come very helpful whenever you need to keep track that, okay, some element I can be at, like what is the maximum and minimum going to check, right? Like for example, now after this, you are trying to check, so where can you lie 6 at? So whenever you need to check where 6 can be at, you basically need to iterate over all elements from 1 to n, check how many people lie in this bunch. So you will get only 2 elements, 7 element lies in the same bag as 6 or not. Correct. Okay, so Mehak said, which is actually correct, that if you need to check that, okay, 7 lies in the same bag as 6 or not, you just basically check that, okay, is L6 equal to L7 and R6 equal to R7 or not. If both these conditions satisfy, that means it is the same range of L and R where 6 and 7 actually sit, and then you can just say, okay, L6, okay, that they lie in the same bunch. You can actually check the position of 4, right? So what changes do I need to make at the L and R values of 4? Any idea? No, sorry, L and R. You just simply said, okay, L4 is simply equal to R4 and that is equal to 4 because and that is equal to cos. So now you basically know that 4 has to sit at the same position cos. Okay, so that completes the implementation. We will try to understand if there are any doubts. Okay, so I have taken n as input, that is the size of the permutation or the size of the graph, and then we take the adjacency list as input. The adjacency list is given as n strings, so we made a vector of string of size n, and we took all the strings as input. The answer is my vector where I will print what is the final answer. as you can see that finally I've just printed answer. Great. I make two arrays L and R. I initialize the L array with 0. I initialize the R array with n minus 1. So that basically shows that, okay, initially all the values can be anywhere from j equal to 0 to j equal to n. So this is a for loop which runs from I equal to 0 to I till I equal to n. Basically, I find out what is the position of 3. Then I try to find out what is the position of 4. So it is something like this. So I loops over all the elements and I check that is Lj equal to Li and Rj equal to Ri. If Lj is equal to Li and Rj is equal to Ri at the same time, that means that means I and j both are at the same back. And if that happens, then I check that, okay, is adjacency Ij is 1. That means is I and j is there is an edge between I and j. If that happens, then we increase the value of count. Okay. So what does CNT store? So that means at some position, so at somewhere midway in the code, where there is a large array, and then you are analyzing some portion, between L and R, and suppose you are trying to check, okay, where I is, and then you looked at all the neighbors j of I which are in the same bag, and you found out that, okay, there are CNT such neighbors where there is an edge between I and j in the same bag. Okay, so where should I place I? Anyone? Where
R
should I?
minus CNT.
Correct. We should store it R minus CNT, right? Always try to look at edge cases, like what is CNT 0? If CNT 0, that means all values are to the left of I. So that means I need to store Li, I at R position. If CNT is 1, I need to store it at R minus 1, so that I leave one extra space for that extra element which will come to the right. So that is what I've done. If you look at the code, so I've kept the position as Ri minus CNT, and I've marked answer pos as I plus 1. So basically, I'm populating this answer array which I will print at the end. Why I plus 1? Because I goes to 0 to n minus 1, so I was using 0 base indexing in my code. But when I need to print the output, I need to use 1 base. Whenever using it, even the further iterations, I look at, okay, is there an edge between I and j? If there is no edge, that means since ij is 1, that means there's an edge between I and j. So we keep the R value same, and we mark Lj as pos plus 1. Finally, after this is done, okay, great. Anyone with exactly that's like, it is very similar to space. Okay, this is given to you as input, so you have to take it. So just reading the input, like you can't just read the string and throw away the inputs, right? Then you will not be able to solve the problem. So this is something which you need to take as input. So this vector string adjacency, and this you have to always make in any solution you write. This is something vi answer of n. This is something which you need to print as output, right? So since you need to print as output, this is also a necessary part of the code. So this is something which you have to make. Apart from that, this is the auxiliary space which we have used. We have taken L and R values, so we have taken L and R values, which basically stores
Yeah.
the coordinates, leftmost and rightmost coordinate. So the auxiliary space for the code is order n, I agree. I'm not very sure if we can do it in order 1. Maybe we can, but I have to think about it once. But in problems where the value of n is so small, it is just 1000, taking order n auxiliary space won't hurt at all, because your time complexity is itself order n square, right? So if the time complexity is order n square, so that means even if you take order n square space, like this, the size of this adjacency matrix is itself order n square. So it is much larger than this L and R arrays, right? So even if you do not make these L and R arrays, the memory space. Okay, Anand says an example where we can do it. Okay, I need to check once. If you can do it, that's great.
Yeah, I too did that way, something similar to like insertion sort.
Okay, great then. Then probably
Yes.
it can be done. I've not thought of it during the contest. I have to think about it once, but but since you all did it, then probably it's great. It can be done then. Okay, but what I explained to you, like this is something I think even this is something which you can like try applying in.
Yeah, insertion sort. Yeah, it makes very much sense now. Uh, so one could have a rank of 2 because there are two ones in front of one and zero zeros behind. Then 2 could have a rank of 3. 3 could have a rank of 1. 4 could have a rank of, and then we can solve that. It's much more easier if we do it in an insertion sort way where um, So, and do it in a descending order. So we can make pairs where okay, I'm back. So we are doing problem D. We are looking into problem D.
Let's
Unique
see
median.
the fourth problem. This is a very good problem. Like uh, unique median. An array B of m integers is called good if uh, when it is sorted the value at m plus 1 by t T floor of m plus 1 by 2 is should be equals to the ceil of m plus 1 by 2. In other words, B is good if both of its median are equal. And in particular, like if m is odd, then both values are same. So
this was my thought process that I went. I just counted out all the odd medians for this question. And then with the evens, I had a problem.
if a subarray, like if the array B is guaranteed to be good if it has an odd length, means all odd length array is good. Now you are given an array of n integers and we have to count the number of good subarrays in A. Number of good subarrays. First, see that like all the odd subarrays are good, and we have to find for even subarray, like even length subarray, like how many even length subarray are 10 to the 5. And see the second problem, like second sample, 1, 10, 2, 3, 3. Here it will become 2, 3, 3, and 10, where both the median 3 are equal. So how to deal with this problem?
The problem I faced was to find which of the even subarrays are the correct ones. So for finding out the odd subarrays for, let's say n is odd, the answer is n by 2 into n by 2 plus 1. And if the n is even, then that would be the answer. And if n is odd, then n square by 4 is the n square plus 1 by 4. So no, sorry, n by 2 plus 1 into n by 2 plus 1. So that would be like for the odd number. So 1 plus 3 plus 5, that is the answer is n by 2 plus 1 into n by 2 plus 1, and 2 plus 4 plus 6 plus 8. The answer is n by 2 into n by 2 plus 1. So that is not an issue, but the issue was to see which of the even subsequences were correct. Good.
First, what I will do is first, uh, like I will find all subarray and I will subtract from all bad subarray, subarrays.
Okay.
Now, number of subarray is equal to,
N into n minus 1 by 2,
and we
n
know
plus
that
1 by
all odd length subarray. So let's do like this one. Elements like the so it basically means this thing here. One element which is should be to deal with less than equals to 2, replace that element with 0. Like replace 1 with 0 because it is less than 2 and equal to 2, and replace it with also 0 and replace it with 0 also. And 1, 1, and 1. Like all the elements which is greater than 2, replace it with 1. So now you can see that the bad subarray uh, has a very unique property that the sum of this array should be equals to L by 2. L by 2. All other like array, which is, if the array is good, then the sum should not be equals to L by 2. You can consider this like if the array is something like this, then it is good because the middle element is basically equal. Middle element is basically equal in this case. I'm considering only two. Current median is 2. So like when this is possible, like if this is the case, then you can't form a partition here, like in the middle. Like it will be a good survey. So what we need to find is basically for all 1 to 10, like consider that element to be median and replace the array with this new array. Like if you are working currently on x, then replace all less than equals to x element with 0 and all greater than x element with 2 or not. This is a solution for one subarray, but you have to find for all subarray. So how to do that? So basically you are given a array like array. Let's fix the element x and do the same just you are doing here, like replace all the elements less than equals to x with 0 and greater than equals to x greater than x with 1. And what you have to find basically the number of subarray whose sum is basically equals to the length of that subarray divided by 2. So how can you do that? First make this array. So let's suppose I have, let's take this sample and let's, I'm considering currently element 2, like 2. So what I will do, I replace it with 0 and then this with 1, this with 0 and then 1 and then 1. Now I have to find like how many subarray is here bad, like this one, because its sum is 1 and the length is 2, and bad subarray prefix sum divided by times prefix minus 2 LHS, and so this will equal to 2 times prefix of r minus r equals to 2 times prefix of L minus 1 minus L minus 1. So you have to find number of indices, like number of L and R, which satisfy this condition. So how to do this? Let's make another array C, whose ith element will be equals to 2.
That's